I'm looking for some ambassadors today. Why I need ambassadors is because most of the times you go out, you always hear somebody addressing mathematics in a negative way. And I think we need to stop that, because learning begins in your mind. And if you always conceive it and then you begin to believe it as being difficult, eventually what will happen? Yes, you will see mathematics as difficult without even attempting to give it a chance. And when you believe in it here and you think that, okay, I'm going to make it, then it becomes a part of you here, where you'll eventually love it. So if you're on Facebook and you see somebody make a negative statement, stop them. You're at home and somebody and say, stop. No, let us think about it the other way. So we're starting in this small group. Mathematics has got to be shown in a positive light. So you are my first ambassadors. You're going to go out and spread the news. Okay? Now, we looked at solving simultaneous equations using the method of substitution. Now let's conquer it again using the method of elimination. Now we have the word elimination. Before we find out how we're going to use it in solving simultaneous equations, let me read for you what it is defined as in the Webster's Dictionary. The dictionary says that elimination means to cast out or get rid of, to cause to disappear by combining two or more equations. So we're getting rid of something. We're casting out something. Now before we can cast out or get rid of, first we have to get the equations. Now I have y take x equals 1, and I have x added to y equals 5. The first one I'm going to call equation 1, and I have equation 2. Now what I need us to do is to rewrite either equation 1 or 2 in such a way that we line up or put in order the variables. We want the y's together and the x's together. Either the x's take the first position or they take the second position. Now which one you want us to rewrite? Equation 1 or equation 2?
Equation 1.
Equation 1. So if we write equation 1, it means that the x would precede the y. Okay? Then we would have a negative x being added to the y. Now we know most of us aren't that strong with integers. So let us deal with one or manage one that we know we'll conquer easily. So we'll rewrite equation 2. Good. So we have y plus x equals 5. Good. This is the same equation 2. But what we have done, we have aligned the y's in the first position, and we have aligned the x's in the first position. So let's write them back. Y take x equals 1, and y added to x equals 5. We have our two equations here. Now y and x, we don't know the value of them, but we know what 1 is and what 5 is. Those are constants, those are numbers that we know. Because we don't know what y and x are, we call them variables. And in front of each variable has a number, but we can't see the number now. Because we can't see it, we know which number appears in front here or is appearing in front there. 1. 1 here, 1 here, 1 there, and 1 there. And that 1 is given a special name. What is the name of the 1? The coefficient. Very good, Kezai. The coefficient. Good. Coefficient. Now normally we would have been taught that 2x is equal to 4. This equation has one variable in it. So to find for x, because we're multiplying here, we're going to take the 2 across and divide. So we do the inverse of multiplication, which is division. And we solve 2 into 2, 1, 2 into 4, 2. Therefore, the value of x here is equal to 2. But we can't solve this. We cannot solve this as we solve this. Because here we have only one variable and over there we have two variables. That brings us to the meaning of elimination. We have got to knock out one of them there to make it look like this. So we can solve for either the x or the y first and then find for the other. Good. So we have identified the coefficients. Now the next thing I want you to pay careful attention to. If we need to eliminate the y or the x, let us pay careful attention to the signs that accompany these variables. What sign accompany? This is what kind of y?
Negative.
The y. Is the y positive or negative?
Positive.
It's a positive y. This y is positive or negative?
Negative.
This y here, is it positive or negative? Positive. So if you don't see a sign in front of it, you know that the symbol or the number is
Positive.
excellent. Good. This x here now, this x here is,
Negative.
and this x is
Positive.
good. Now since you know that these coefficients are 1, I'm going to take them off because I have a brilliant bunch of children here with me. So if we need to knock out the y or knock out the x, which pair would you choose to knock out, the x or the y? And the y. Which pair is easier to get rid of?
The positive. The greater.
Why? And you got to tell me why. We have two positive y and we have a negative x and a positive x. And again, the coefficients are the same. So which pair would you choose at y? Yes, Kevin, you would choose the x's to get rid of?
Negative x.
The negative x. Now remember, when we're done, we must only have one variable. Either we have the y's alone or the x's alone. Okay? So, when we're getting rid of a pair, when you finish, you wouldn't see any y. Yes, so which pair should we get rid of?
The x.
The x's.
Because it has two different signs.
Excellent. Brilliant. Excellent. So, you have chosen the x's because,
Two different signs.
first of all, the coefficients are the same and then they have
Two
different signs. Good. So what operation must we put these two equations through to get rid of? Sorry, I've already given you the answer. The question I wanted to ask you, what must we do to the two equations so that we get rid of the x's? Should we add the equations or should we subtract the equations? We should add them. Good. So when we add one y to another y, we end up with how many y's?
Two y's.
Two y's. When we have a negative x and we add it to an x, we end up with a
Positive.
positive x. We have a minus x and we add it to an x. And what do we have?
Negative x.
Are you sure? Now let's go again. I'm going to swing this around. We have an x and we're taking an x. And what do we have?
Negative x.
If we have an x and we take an x, what will we be remaining with? No x, 0. So all we did, we took this and we swung it around, or we rewrote it, and this is where we ended up with. And this, if we have 1 and we take 1, we're left with nothing. So here we're left with nothing. And if we have 1 and we add it to 5, we end up with 6. Do you see an x here now?
No, miss.
So it means that the x has been
Eliminated.
good. Eliminated. So let's write the equation now. So we have a linear equation now. 2y's equals 6. What operation is taking place between the y and the 2? Multiplication. Now our aim is to find the value of what here? The value of what in this equation here? The value of y. Now y is the unknown. 2 and 6 are known, so we're going to work with them. So we're going to move the 2 from the left hand side and take it across to the right hand side and do what?
Divide.
Why do we divide?
Because when the sign goes over the equal sign, it changes.
So we use the inverse of the operation. And the inverse of multiplication is division. How many 2's are there in 6?
3.
3 2's. This implies that y has a value of 3. Now that we have gotten rid of x and we found y, remember our original equations have an x in them. So we have got to go back now and find the value of x. So now that we know the value of y, what do you think we should do with this 3?
Use it.
Yes, Denisha?
I substitute the y and put 3.
Substitute the y where? Where do we take it to s equal bump with 3? In the equation that we originally given. Any one of the two you take. So we have y take x equals 1. That's what we were given here. Good? What is y? 3. So we're substituting y equals 3 here. Take x is equal to 1. Now let us make our work a little simple. We're going to take the x across and bring across the 1. Good? So if we take a negative x across, it becomes
Positive.
so 3. And if we bring across the 1, it becomes
Negative.
or we have to subtract. 3 take 1 is equal to x. This implies that 2 is the value of x. Now let me show you why it is simpler to work like this instead of this way. Here we had 3 take x is equal to 1. Now normally you would have had to move the 3. So you would have been left here with a negative x equals to 1 take 3. So a negative x is equal to a negative 2. So sometimes you have got to use some wisdom and look at the signs that are coming. You can see the signs before and try to eliminate them so that your life is simpler, easier. And once you make mathematics easy for yourself, then after that you just cruise through. Okay? Good. So even though we had minus x is equal to minus 2, this implies that x is equal to 2. You have the same answer. So our solution, when x is equal to 2, y is equal to 3. But we're not sure. Are we sure? Are we absolutely certain? No, we've got to go back and test our answers. So let's go back and test them. Our first equation said if we take y, take x out of y, we're going to be left with 1. Y is 3, x is 2, and what we're left with?
1.
So our answer on the left is equal to our answer on the
Right.
But that was only the first one. They must work in both. Let's try the second one. When we add x to y, we're going to get 5. Value of x?
3.
2. And we're going to add that to 3 and we should have a
5.
The value on the left is equal to the value on the
Right.
hand side. So there we have found the values which should satisfy these equations here at the same time or simultaneously. Okay? And we have used the method of elimination to assist us. We have gotten rid of or we have knocked out so that a condition can be created where we can solve the find equation. Now we have to be very careful when we're making decisions. First, we had to observe the coefficients. Then we looked at the signs. And then we made a third decision. Should we add or should we subtract? Because the signs are unlike, we decided that we must add. Good? Take a quick jotting of what you have there. So equation 1, A is equal to 4, take B. And equation 2, 2A plus B equals 1. That's equation 2. Now I want you to write those equations, and what are you going to do with them for me? You're going to, the first step, are they in order where the variables are lined up? No. So that's the first thing you're going to do. Copy the equations and arrange them in a form like this. So when we're done, we must see something like this. That's the first step. So we're rearranging the variables, right? So the B must be under the B and the A under the A. On the B now. Would anybody like to volunteer what they have? Ashley, you want to share yours with me? Come on, don't be afraid.
That's 4A take away B's.
4A, how about 4A?
No, Miss said the A's on the A's and the
B's under the B's, So, let's rewrite this one here to look probably like this one. So we'd have A. So if the B is negative and we're bringing it across,
It's a positive.
plus B, and that would be equal to 4. Okay? So this is still our same equation 1, but we rewrote it in such a way that we have the A under the A, the B under the B, and the constants together. So that's the first thing you must do. Put them into perspective where you can see the variables, where you can see the symbols, where you can see the coefficients, where you can see the signs. Good. So when we look at the coefficient of the A's, 1 is a 2 and 1 is a 1. And in B, what do you observe? Where do you observe about the coefficients in the B's, with the B's?
They're all ones.
They're all 1s. That means that they are the same. Same. Good. So if we want to eliminate or knock out one of the variables, which one would you choose?
A.
Why would you choose A, Denisha?
Because it only has one.
Because it only has 1. We have 2 here. We have 1 here.
And it's because they're not the same.
Because they're not the same. Yes, Miss Hamilton. Which one would you choose?
B, because they're both are the same.
You choose B because the coefficients are the same. But one other condition must be present make you choose B. What is that condition? The variables are the same. And one other thing you need to look at, apart from the coefficients being the same, what is the other thing you need to look at? The signs. And both of them have the same sign. And if both of them have the same sign, it tells you that you're going to have to, what operation you're going to have to perform on those two? Oh, what's the operation of? Elimination. Yes, you're eliminating. But then we have 4 basic operations that we use. We call them the 4 basic arithmetic operations. Addition,
Subtraction, multiplication, and division.
Good. So to eliminate this B, which one of the 4 should we perform on these two? On those 2 equations to eliminate the B? We should subtract. Good. So we're going to take away. So let's take away. 2 A's, take an A would leave us with an A. A B, take a B would leave us with 0. A 1, take a 4 would leave us with
3.
You have 1 and you take out 4
And negative
and negative 3. Now I want you to finish off working this equation here. Find the value of B. So here we know that A is equal to negative 3. So if we found, like we did across here, when we found the value of one of our variables, we took that value and we substituted back into any one of these two equations. So we have the value of A. We have to choose whether we want equation 1 or equation 2. We're going to substitute A into any one of these two to find for B. So which one of them are you going to choose, equation 1 or 2? Your choice. Equation 1. Equation 1, we're using this one, says when we take A and add B, the outcome is 4. Instead of A, what are we going to put? Negative 3. Added to B equals 4. B is equal to, tell me what I should write now. What is B equal to? What should I write across here? B is equal to? How did you get 7? Yeah. Very good. Very good, Miss Hamilton. We're going to add the 3 because the inverse of division, subtraction is addition. So we bring across the 3 and we're going to add it. Therefore, B is equal to 7. So when A is negative 3, the value of B is 7. And these two values we're going to put into here and here to make sure that the equation right side balances with left side. So let's prove that. 2 A's added to B equals 1. 2 multiplied by A, which is negative 3, plus B, which is 7, equals to 1. When a positive is multiplied by a negative, you have a negative. 2 3s are
6.
If we have a negative 6 and we add a 7, what will we get? A positive 1. Let's try the other equation. A plus a B equals 4. A is negative 3 plus 7 equals 4. Now when you see an operation on like this, just interchange the values. So you have a 7 takes 3 and you have 4 as your result. Yes. Okay? So our solution, when A is equal to negative 3, B is equal to 7. Let's look at a third example. Two A's take 2 B's and we have 1 as the difference. And we have 3 A's take 4 B's and the difference is 1 again. Equation 1, equation 2. I want you to pause and look at those two equations and examine the conditions that are necessary that I told you about. We looked at coefficients, we looked at signs, we looked at what operation in the end must be done. And tell me what you think. What approach are we going to take to solve this one? In the first case, all the coefficients were the same. In the second example, the coefficients of the variable b were the same. Will you notice in the third example?
Both of the variables each same are the same.
Each what is the same, Monica?
Miss the variable.
Yes,
Both
Denisha.
the variables and the signs are in the place.
Both the variables and the signs are in place. Explain to me further.
It's like when you have to move them to
Mhm.
get them correctly.
Very good observation. They have already been lined up. So we have the A's and the B's and the constants. Very good observation. Very good. So we have already lined them up. Next condition, we talk about the variables. What can you tell me about the variables? None of them in the pairs. We're looking at them as a pair. None of them are the same. So we have a 2 and a 3, a 2 and a 4. So we cannot go ahead as we did here and what we did here, we added and across there we subtracted. We have no pair that has the same coefficient. So if no pair has the same coefficient, and if you notice, if you were observing keenly, in order to eliminate a pair, you have to get the same coefficient. That was a must. So if you have to get the same coefficient, what must we do here to come up with the same coefficient, to arrive at the same coefficient? What do you think can possibly happen? We have a 2 and a 3, a 2 and a 4. Any suggestion? What do you think we can possibly do to make any pairs the same? Yes, Ashley?
Let's divide the 2 by the 4, miss.
Divide the 2 by the 4, but if we divide the 2 by the 4, we're going to get a half. Remember, we have to make them the same. Anybody else have any thought? What do you think we can do to make these two the same? But I think it would be easier to work on these two. We have a 4 here, we have a 2 here.
Miss,
Yes, Monica.
Miss, multiply the 2 by 2 together.
Multiply the 2 by a 2 to get a 4. Now remember, this whole thing is an equation. So if we interfere with the brother, we have got to touch the sister as well as the mother. Good? You can't touch the brother alone. Good. So we're going to take the entire equation 1 and we're going to multiply by 2. So let's go. 2 2s are 4 A's. Take 2 2s are 4 B's. And that would give us 2 by 1 gives us 2. So here we have made the coefficient of the B the same. So we have changed equation 1 by multiplying by 2. So we're going to call this equation 3. That's our new equation. So the first thing, we lined them up. The second thing, we made the coefficients the same in one variable. What's the third approach? What should we look for now?
Miss, this is variables and coefficient that matches with
Miss the sign, miss.
We're looking at the signs now. Yes, actually, you tipped it nicely. We're looking at the signs now. So the coefficient condition is there. So we're now looking at the signs. Both of them are negative. So what are we going to do? Are we going to add or are we going to subtract? We're going to add. You sure you want to add?
Yes, miss.
Okay. So we have, let's add and see what we're going to get. We're adding equation 2 to equation 3. 3a's plus 4a's would give us 7a's. So I'm going to write this down. A minus 4b plus a minus 4b. And what did that give me? When a minus and a minus plus and accompany one another, which sign rules here? Minus. So we're going to have a minus 4b minus a 4b, and that would give us a minus 8b's. So can we add?
No.
No, we can't add. So what should we do?
Take ring.
We have to subtract. We have to subtract. So the operation would be subtraction. But remember, I told you that in doing mathematics, you have to try as much as you can to make life easy. Now let us examine again the coefficients. We have a 4a and a 3a, a 4b and a 4b, that's fine. We have a 2 and a 1. If we want to subtract and you want to make life easy, which equation should be at the top and which one should be at the bottom? We're looking at equations 2 and 3. Which one should be on top and which one should be at the bottom? 3 should be on top and 2 at the bottom. So let's go again. 4a, take 4b equals 2. 3a, take 4b equals 1. And we said we're going to subtract. If we have 4a's and we take 3a's, we left it an? We left it an A. If we have a negative 4b and we subtract a minus 4b, what will we have? A 0. We'll have a 0. And when we have a 2, take 1. We left it a
1.
Therefore, this implies that A is equal to 1. Now that you know A is equal to 1, can you find the value of B?
Yes.
How would you go about finding the value of B? Substitute A equals 1 in either equations 1 or 2. Work. Would anybody like to volunteer the equation they chose? Miss Hamilton? Which equation you took? Equation 1 or equation 2? Equation 1. 2a, take 2b equals 1. Which one of the variables you know the value of? A. So instead of writing A again, we're going to put 1. We have to bring back our 2b because we don't know the value of b. So we're going to multiply here. 2 multiplied by 1 will give us a
2.
Good. So here we have a 2 take a 2b equals 1. So again, we make life easy. We're going to take across the 2b and it's going to become positive, and we're going to bring across the 1 and subtract. So we have 2 take 1 equals 2b. 2, if we take 1, we left with 1, is equal to 2b. 1 divided by 2, which is a half, is equal to b. So when A is equal to 1, B is equal to a half. Let's make sure we're correct. So we have 2 A's, look, take 2 B's, take 2 B's, and we have a 1. So we have 2 multiplied by 1, take 2 multiplied by a half equals 1. 2 ones, 2 ones. So we have 2 take 1 equal 1. Left hand equals right hand. Good. Let's try the second one. 3 A's, take 4 B's equals 1. 3 multiplied by 1, take 4 multiplied by a half. A half of 4 would give us 2. 2 ones, 2 twos. 3 by 1 is 3. Take 2 equals 1. Left hand equals right hand. Good. So our equations are balanced. We know definitely that these two values will satisfy these two equations. Good. Now let's quickly go over as a procedure. The first thing you do, as Denisha said, we make sure our variables are aligned. Let the A fall under the A and the B. You set them up neatly. Then, after that, what do we look for? Word begins with C.
Coefficient.
Look for the coefficients. Because we're using this method where we're knocking out or getting rid, we have to pay keen attention to the coefficient. If the coefficients are not the same, what do? We have to make them the same. And as you did here just now, we multiplied one equation by 2 to make the coefficients the same. So here we took our first equation, multiplied by 2, and we got here. But in the first case, we hadn't to do that because that condition was already there. Good? So after aligning and making the coefficients the same, what do we look after that? We look at the signs. When the signs are the same, what operation is taking place? The operation of subtraction. When the signs are different, what did we do? We added. Good? And when you're finished, give it a check. Check to see if these two that you got in the end, when we put them back into the original equation, the right hand side is equal to the left hand side. Okay. Lesson 24, Algebra, Simultaneous Equations. In this lesson, we will solve simultaneous equations using the method of elimination. Here are some key points. A system of simultaneous equations is a set of 2 or more equations in 2 or more unknowns. A solution of such a system is a set of values of the unknowns that satisfies every equation of the set simultaneously. Simultaneous equations can be used to solve many real-life problems. Example 1. Solve the equations negative 2a take 3b equals negative 4. 2a take b equals 4. Solution. Step 1. Rewrite the equations as negative 2a take 3b equals negative 4. Call it equation 1. 2a take b equals 4. Call equation 2. Example 1 continues. Step 2. Equation 1 plus equation 2 gives negative 4b equals 0. Then b equals 0. Step 3. Substituting 0 for b in equation 2 gives 2a take 0 equals 4. 2a equals 4. A equals 2. Hence, a equals 2, b equals 0. Example 2. Solve 2x take 3y equals 2 3x plus 2y equals 16. Step 1. Rewrite the equations as 2x take 3y equals 2, equation 1. 3x plus 2y equation equals 16, equation 2. The coefficients of x have different absolute values. The coefficients of y have different absolute values. Example 2 continues. Step 2. We make the different coefficients of one of the unknowns have the same absolute value in both equations. Equation 1 by 2 gives 4x take 6y equals 4, equation 3. Equation 2 multiplied by 3 gives 9x plus 6y equals 48, equation 4. Now the y's have the same absolute value, that is 6. Example 2 continues. Step 3. Since the y's have opposite signs, we add the two equations, equation 3 and 4, to eliminate them. Equation 3 plus equation 4. Equation 3 is 4x take 6y equals 4. Equation 4, 9x plus 6y equals 48. 4x plus 9x take 6y plus 6y equals 4 plus 48. 13x equals 52. Therefore, x is equal to 4. Example 2 continues. In order to find the corresponding value of y, we have two options. Option 1. We can substitute 4 for the value of x in any of the original equations. Substitute in equation 2. 3x take 2y equals 16. 3 into 4 plus 2y equals 16. 12 plus 2y equals 16. 2y equals 16. Take 12. Y is equal to 2. Example 2 continues. Option 2. Instead of substituting x in order to find y, we could go back and start again with the original equations and eliminate x instead. Equation 1 multiplied by 3 gives 6x take 9y equals 6, equations 5. Equation 2 multiplied by 2 gives 6x plus 4y equal 32, equation 6. Example 2 continues. Since the signs are the same, we subtract the two equations. Equation 5 take equation 6. Equation 5, 6x take 9y equals 6. Equation 6, 6x plus 4y equals 32. 6x take 9y, take 6x plus 4y equals 6, take 32. 6x take 9y, take 6x, take 4y equals negative 26. Negative 13y equals negative 26. Y is equal to 2. Note, the second option is particularly useful when the first value found has a fractional value and might give rise to difficult working when substituted. Example 2 continues. Check 1. 2x take 3y equals 2 by x, which is 4. Take 3 by 2, which is y, equals 2, which is equal to 8. Take 6, which is equal to 2. Left hand side equals right hand side. 2, 3x plus 2y equals 3 by x, which is 4, plus 2, which is b, equals 16. 12 plus 4 equals 16. Left hand side equals right hand side. Example 3. Two farmers took their wives to market and then went to buy chicks. Mr. Ram bought 10 chicks and 2 ducklings, and Mr. Jones bought 7 chicks and 4 ducklings. When they rejoined their wives for the return trip home, both farmers had problems in remembering how much they paid for each chick and each duckling. Example 3 continues. However, Mr. Ram remembered that he had paid $248 altogether and Mr. Jones paid a total of $321. Miss Ram, who was a mathematics teacher, had a solution for the problem. She worked as follows. Solution. Suppose X dollars was the price of a chick and Y dollars was the price of a duckling. Then Mr. Ram paid 10x plus 2y for his 10 chicks and 2 ducklings. Hence, 10x plus 2y equals 7x plus 4y equals 321. Let us eliminate y. Equation 1 multiplied by 2 gives 20x plus 4y equals 568. Equation 2, take equation 3, gives 20x plus 4y equals 568. 7x plus 4y equals 321. 13x equals 247. X equals 19. Here is another method. Equation 1 multiplied by 2 gives 20x plus 4y equals 568. Equation 2, take equation 3, gives 7x plus 4y, take 20x plus 4y equals 321, take 568. 7x plus 4y, take 20x, take 4y equals negative 247. Negative 13x equals negative 247. X is equal to 19. Let us substitute 19 for the value of x in 10x plus 2y equals 28. 10 by 19 plus 2y equals 190 plus 2y equals 240. 284. 2y equals 284. Take 190. 2y equals 94. Y is equal to 47. Hence, the price of one chick is $19. The price of one duckling, $47. Summary. Simultaneous equations can be solved by method of elimination. An equation remains the same if every term is multiplied or divided by the same quantity. The solution of equations must always be checked. Substitute the solutions in the original equations. Left hand side must be equal to right hand side. Problems for today. It's taken from Mathematics for Secondary Schools in Guyana, Book 3, page 69, exercise 5E, question 14, page 71, exercise 5F, question 2. Solution for the problems given in the last lesson. Page 68, exercise 5E, questions 12. Solve the equation 2x plus 3y equal 5 and negative x plus 2y equals 8. Solution. Step 1. Rewrite the equation as 2x plus 3y equal 5, equation 1. Negative x plus 2y equals 8, equation 2. Solution for the problems given in the last lesson continues. Step 2. Since the coefficient of one of the variables in the given equations is 2, express one unknown in terms of the other. From equation 2, negative x equals 8, take 2y. X is equal to 2y, take 8, equation 3. Solution. Step 3. Substitute 2y, take 8 for x in equation 1. 2x plus 3y equals 5. Then 2 into 2y, take 8 plus 3 equals 5. Step 4. Clear the brackets and simplify. From 2 into 2y, take 8 plus 3y equals 5. We get 4y take 16 plus 3y equals 5. 7y equals 21. Let us solve for y. Y equals 3. Solution for the problems given in the last lesson continues. Step 5. We know that y equals 3. Let us substitute the value of 3 for y in equation 3. X equals 2y. Take 8. X is equal to 2 by 3. Take 8. X is equal to 6. Take 8 equals negative 2. Hence, x equals negative 2, y equals 3. It is always important to check your solution. In equation 1, 2x plus 3y equals 5. 2x plus 3y equals 2 by x, which is negative 2, plus 3 by y, which is 3, equals 5. Left hand side equals right hand side. In equation 2, negative x plus 2y equals 8. Negative x plus 2y equals negative 2 plus 2 by 3 equals 2 plus 6 equals 8. Left hand side equals right hand side. Solution for the problem in the last lesson. Page 71, exercise 5F. Find the cost of a pencil and eraser if 2 pencils and 3 erasers cost $140 and 5 pencils and 4 erasers cost $280. Let P equal the pencils, E the erasers. 2P plus 3E equals 140, equation 1. 5P plus 4E equals 280, equation 2. P equals 140, take 3E divided by 2, equation 3, we get that from equation 1. Substituting P equal 140, take 3E divided by 2 in equation 2 gives 5 into 140, take 3 divided by 2 plus 4E equals 280. 700 take 15E all divided by 2 plus 8E divided by 2 equals 560 divided by 2. 700 take 15E plus 8E equals 560. Negative 7E equals negative 140. E is equal to 20. Substituting 20 for the value of E in equation 3 gives P equals 80 divided by 2, which is equal to 40. P equals to 40. Take 3E divided by 2. P is equal to 40. Hence, 1 pencil costs $40 and 1 eraser costs $20. So that is how the method of elimination would aid us or help us in solving 2 equations at the same time that has 2 variables.